All right, guys, welcome to 5.3. We're going to look at malfunctions in homeostatic mechanisms. Basically, we're going to look at a whole bunch of conditions in which homeostasis has failed. Okay, let's start with diabetes. Diabetes mellitus is a metabolic disorder, right, in which the body is unable to regulate its glucose levels. It is characterized by hyperglycemia or high blood sugar levels, right? There are three types of diabetes. You have type 1 diabetes, which is juvenile diabetes, and it is insufficient insulin production by the pancreas. Type 2 diabetes is what we call onset diabetes, where you have an insulin resistance by the body's cells. And then you have a third form, which is gestational diabetes. It's a temporary form of diabetes in pregnant women. And it also causes insulin resistance, and usually it goes away after childbirth. However, sometimes it can lead to onset diabetes as well. On a side note, diabetes can also have effect on eyesight in a condition known as diabetes retinopathy, right? Here's a diagram of what a diabetic eye looks like, where you get these kind of little cotton wool spots in the eyesight, and it affects your vision in a few kind of wacky ways. And often optometrists will diagnose diabetes based on a person's eyesight, which is really interesting. Okay, let's take a look at type 1 diabetes. Type 1 is caused by a malfunction of the pancreas, and type 1 diabetes is what we call an autoimmune disease. An autoimmune disease is when the body's immune system destroys its own cells. In the case of the pancreas, it is the destruction of the beta cells, the ones that are producing insulin. So death of the beta cells lead to a lack of insulin production. And without the insulin, the body's not going to be able to absorb any glucose, and you get a high blood glucose level, leading to hyperglycemia. Here is a graph showing three individuals. One is a non-diabetic, and you can see the blood glucose level after a meal, after about an hour or so after you eat the meal, should go up, and then it's going to go back down again because your body's then releasing insulin, telling your cells to absorb it, and then it goes back down to a stable state. In a pre-diabetic individual, you can see the process starting to spike in the blood glucose level a lot more and then slow down because the body is slower to respond to the changes in glucose and is unable to correct that change as rapidly. And then in a diabetic, you can see it's completely broken down because the glucose spike is really high. And then on top of that, it doesn't take a quick amount of time to go back down, or it doesn't go back down fully at all. And so you have to manage it in another way. Symptoms of type 1 diabetes include glucose in the urine or increased urine production to try and get rid of it, excessive thirst or hunger, weight loss, fatigue, or blurry vision and irritability. Usually symptoms are pretty consistent with hyperglycemia. To manage type 1 diabetes, well, you can do a few things. You can reduce the amount of intake of high sugary foods. You can also inject insulin into the body as well. So you can take a little finger prick to get a blood sample of a drop of blood, and then you can then see what your blood glucose level is. And if it's too high, you can then take an insulin injection to bring it back down. Some people also have a little electrode that does it for them automatically, so that it can be connected under the skin and connected to a device. And then if it's connected to a pump, you can also deliver the insulin automatically. So you don't have to think about it, but your body can read, detect, and respond accordingly all the time. You can also take pancreas transplants. So you can transplant part or the whole pancreas. If you do part or just a few cells, it's called an islet transplant. However, if you take pancreas transplants, you have to take immunosuppressant drugs to make sure that the immune system doesn't attack the transplanted pancreas or part of the pancreas cells, right? There's this new thing called gene therapy, in which you can then insert codes for the production of insulin into the patient's cells. And there are trials in the US on rat livers that have been successful in producing insulin in the livers of these rats, which means that the body can produce its own insulin without the need of a functional pancreas. That also means you don't require immunosuppressants, which is pretty neat. Now, type 2 diabetes occurs when the body develops insulin resistance, okay? That means that the cells in the body are not responding to the excessive insulin levels in the blood, right? So in type 1, you have no insulin production, but in type 2, you have insulin production, but the body's not really receiving and taking it in, which means it's not responding to taking glucose either, and you get hyperglycemia nonetheless. Now, type 2 diabetes develops over the course of an individual's life. Type 1 is genetic, type 2 is primarily based on diet and lifestyle, and it accounts for about 85% of the diagnosis in Australia, right? Here is a graph showing you the number of diabetic people over the last decade going up, and then you can see that it actually correlates with the number of overweight or obese people. So there's a strong correlation between type 2 diabetes and obesity, giving you an idea how much of an impact diet and lifestyle has on onset diabetes. How do you manage it? Well, you can manage it by decreasing the amount of carb you eat in your diet. You can exercise. By exercising, you increase the ability of the body to be sensitive to insulin. And then you can also take medication to increase absorption of insulin by the body and therefore glucose, or decrease production of glucose by the liver. Okay, the next set of conditions we're going to look at involves the thyroid gland and the thyroid system. So I'm going to explain how that works, right? Your thyroid is a gland located underneath the throat, and it is responsible for hormones that regulate metabolism and energy use, right? So that regulation includes things like your cardiovascular system, breathing and heart rate, your metabolic system, your basal metabolic rate, appetite and absorption, growth and development, and then also things like sexual function, menstrual cycle, sleep, and thought patterns, right? How does it work? Well, the thyroid system works by releasing two hormones, thyroxine and triiodothyronine, right? T3 and T4. I'm just going to call them T3 and T4 because they're just hard to pronounce, especially this one here. Balancing the right levels of these hormones are regulated by the hypothalamus and the pituitary gland, right? So the hypothalamus, which is your body's thermostat, reads a bunch of your different conditions, and then it releases thyrotropin-releasing hormone, or TRH, which then goes to the pituitary gland. And then the pituitary gland is then going to release thyroid-stimulating hormone, or TSH, onto the thyroid. Then, in response to that, the thyroid then releases T3 and T4 around the body, and that's going to increase your metabolism. It's going to make you use more energy. It's going to increase your growth and your development and things like that as well. Okay. When you have malfunction of the thyroid, you can have either hyperthyroidism or hypothyroidism, and we're going to go through each one. Hyperthyroidism is when you have too much T3 and T4, right? So you've got too much and your metabolism is rising up too much, right? It has a widespread effect on other organs in the body, including your basal metabolic rate, which increases your body temperature and your heat intolerance, right? Because your metabolism is how your body uses energy, by increasing your metabolic rate, you're going to increase the amount of body energy your body is burning, therefore makes you heat up a lot more. So everyone around you in the room feels like it's a pretty, cool weather and isn't too worried about the heat, but then you're feeling overheated because your metabolism is too high, right? You also get a decreased appetite and weight loss, and then it also leads to excessive GI contractions and diarrhea, right? And also, in some people, you also get a visibly large goiter, which is obviously a swollen thyroid, and you can see that in this image here. Common cause of hypothyroidism is actually Graves' disease, which is actually an autoimmune disease where the production of a particular molecule called the thyroid-stimulating immunoglobulin mimics the thyroid-stimulating hormone. So you now have an immunoglobulin molecule that acts like a hormone, and it results in the excessive production of T3 and T4, right? Therefore giving you hypothyroidism. How do you manage hypothyroidism? Well, you can take these things called beta blockers, which are going to slow down your heart rate and your tremors, but they're not really going to solve the main problem, right? To fix the problem, you can take anti-thyroid drugs, which are going to inhibit the hormones produced by the thyroid, and you just kind of keep taking these drugs. If you want a more permanent treatment, you then would take radioactive iodine treatment, right? Your thyroid cells will absorb the iodine, and therefore if you have radioactive iodine, it's going to take it into the cells as a pill, and then it's going to kill those cells with radioactivity, right? And that's a more permanent method, right? If you want to, you can also take surgery, which can remove part or all of your thyroid. However, if you do that, then you need to take drugs and hormones to then stimulate the body to keep its metabolism up. Otherwise, you encounter new problems as well, right? Now, the other condition you can have is hypothyroidism. Hypothyroidism is a condition in which you have insufficient production of thyroid hormones, right? And the wide range of symptoms that includes is the opposite, right? Lower metabolism, you get a weight gain because your body's not burning up energy as quickly. You get lethargic because you're not burning up energy as quickly. You get a slower heart rate and you become more sensitive to the cold. The main cause of hypothyroidism is actually a lack of iodine in your diet. So when you don't take enough things like fish, for example, you might lose a bit of iodine in the diet. And iodine is really essential because, as we said earlier, right, the thyroid cells need to absorb iodine to function. And so by absorbing iodine, you get production of T3 and T4, right? Okay, that's it for this particular video and this particular chapter. I hope you guys enjoyed it, and I will catch you guys next time.